Welcome to ClickMyProject.com. Let me discuss about the process VMAC, a TDMA based MAC protocol for reliable broadcast in VANETs. Let me discuss about the abstract of the project. Most VANET applications are built upon the data push communication model, where information is disseminated to a set of vehicles. In vehicular ad hoc networks, vehicles transmit traffic and safety related information, including traffic congestion, avoidance messages, accident warnings, accident reports, etc., which assist drivers in making proper decisions to avoid vehicle collisions and congestion. Vehicular ad hoc networks are created by applying the principles of mobile ad hoc networks. The spontaneous creation of a wireless network for data exchange to the domain vehicles, they are key component of intelligent transportation systems. VANET support a wide range of applications, from simple one-hop information dissemination to a cooperative awareness messages to multiple hop dissemination of messages over vast distances. Most of the concerns of interest to mobile ad hoc networks are of interest in VANETs, but the details differ. Rather than moving at random, vehicles tend to move in an organized fashion. The interaction with roadside equipment can likewise be characterized fairly accurately. And finally, most vehicles are restricted in their range of motion. For example, by being constrained to follow a paved highway. In this project, the system presents VMAC, a novel multi-channel TDMA protocol proposed specifically for a VANET scenario. Let me discuss about the flow diagram for our process. Initially, acquire time for slot has been initialized. The objective of the analysis is to investigate how fast the contending nodes can acquire a time slot on channel by using a VMAC protocol. Let K denote the number of contending nodes, each of which needs to acquire a time slot on channel. The system wants to determine the average number of nodes which acquire a time slot within n frames, the probability that a specific node acquires a time slot within n frames, and the probability that all the nodes acquire a time slot within n frames. Next, the transmission probability has been estimated. All the contending nodes belong to the same set of THs with the same node W and X and in its final position. The set of THs to which the contending nodes belong does not change. The set A is not which the contending nodes belong does not change. The set A is not augmented when a node fails to acquire a time slot after frames. At the end of each frame, each node is aware of all acquired time slots during the frame and updates the sets T0 and A accordingly. All the nodes are within the communication range of each other. At the end of each frame, all contending nodes are informed whether their attempts to access a time slot during this frame. Based on this information, each colliding node randomly chooses an available time slot from the updated. Next, the average number of nodes or acquired time slots. The probability of all nodes acquired time slots has been estimated for both highway and city. The first scenario under consideration is a segment of two-way vehicle traffic highway. Vehicle can communicate with all vehicles within its communication range. That is no obstacle. Each vehicle moves with a constant speed drawn from the normal distribution, and the number of vehicles on the highway segment remains constant during the simulation times. When a vehicle reaches one end of the highway segment, it re-enters the segment from the other end. The second scenario is a city grid layout consisting of 3 horizontal and 3 vertical two-way vehicle traffic streets. All the streets have the same dimensions, and the horizontal and vertical streets are evenly spaced, relating in 4 identical square city blocks. Finally, the performance has been analyzed. The reduction of access collision rate by using fixed time frames and new method for the nodes to access the available time slots. The reduction of the merging collision rate by assigning disjoint sets of time slots to vehicles moving in opposite direction and to RSUs, and the SRP conditions which prevents the nodes from unnecessarily releasing their time slots when they just enter the communication range of each other. Compared with the ad hoc MAC enhanced protocols, the VMAC provides a smaller rate of transmission collision, which results in a significantly higher throughput on the control channel. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, write in the file and run for executing this process. Here we perform the VMAC protocol for VANET applications for both highway and city scenario. We obtain the performance result. This is the forward all graph, the probability that all nodes acquire a time slot within n frames. Based on the number of frames, the probability of acquire time slots for all nodes. This is the snapshot for the simulated highway segment. This is the left right directions for our vehicle movement, and this is the right direction for our vehicle movement, and this is the rate of merging collision by varying the THSO for our existing and proposed system. This is the rate of access collision by varying the THSO for our existing and proposed systems. This is the transmission throughput for highway, here by varying the THSO for our existing and proposed system. And this is the receiving throughput for highway by varying the THSO for existing and proposed system. And this is the city segment snapshots for vehicle movement. And this is the rate of merging collision for the city scenario for our existing and proposed systems. And this is the rate of access collision by varying the THSO between existing and proposed systems. This is the transmission throughput in city scenario by varying the THSO between our existing and proposed systems. And this is the receiving throughput in city scenario by varying the THSO between existing and proposed system. Finally, we analyze the best throughput and also collision occur in a merging and accessing process for both highway and city scenario. Thank you.